Lesson 2, Addition and Subtraction of Vectors, Part 1. Considering the given figure from A to C can be accomplished in two ways. One, from A to B, from A to B, then to BC. From A to B, you have displacement vector AB, and then from B to C, you have displacement vector BC. 2. Directly from A to C, a single displacement vector AC. The vector AC is said to be the sum of vector AB and vector BC. We write this as vector AC equal to vector AB plus vector BC. Or simply put, C is equal to A plus B. The law that vector AC is equal to vector AB plus vector BC is called triangular of vectors. The vector A plus B is called the resultant of the vectors A and B. From the definition of negative vector in lesson 1, we can say that subtraction of a vector is the same as the addition of its negative vector. Let's consider figure 5. You have P arrow, PQ, PS, arrow Q, QS. From figure 5, vector QS is equal to minus vector Q arrow. Now, there is difference between vector arrow Q and vector Q arrow. Want to get the subtraction? Vector PQ minus vector Q arrow is equal to vector PQ plus minus vector Q arrow. These two expressions are the same. From here, if you interchange the position of Q and arrow to arrow Q, this sign becomes positive. So you have vector PQ plus vector arrow Q. Note the change in minus vector Q arrow to vector arrow Q. Vector PQ is equal to QS. This vector that is equal to this is equal to QS. And when you combine these two vectors under addition, because they have a common point Q and Q, the result is simply vector PS. Figure 5 demonstrates the sum and difference of the vector. If vector PQ is equal to A, that is this point, vector Q arrow is equal to B, vector Q arrow is equal to B, vector QS is equal to minus B, then vector P arrow is PQ plus Q arrow, that is A plus B. Then vector PS is equal to A minus B. A minus B. Generally, in matrix notation, if vector A is equal to this, a column matrix, and vector B equal to another column matrix, vector A plus B is the addition of the two column matrices. You do that corresponding element to corresponding element. You have S1 plus Y plus S2. S1 plus S2, that is the first entry. The second entry becomes Y1 plus Y2. Parallelogram law. Figure 6. The parallelogram law of vector addition states that the resultant of two vectors is represented by the diagonal of the parallelogram whose adjacent sides are the two vectors. From figure 6, vector PQ plus vector PS is equal to vector PQ plus vector Q arrow. The law we are discussing for vector addition is seen as being equivalent to the triangle law of vector addition. This law of parallelogram and that of triangle law both are equivalent. Addition of several vectors. Suppose there are more than two vectors to be added. The triangle law of vector addition can be used repeatedly to add more than two vectors. From figure 7, vector PQ plus vector Q arrow is equal to vector P arrow. P arrow is equal to PQ plus Q arrow. Then vector P arrow plus vector arrow S is equal to vector PS. Vector PS plus vector ST is equal to vector PT. Hence, vector PQ plus vector Q arrow plus vector arrow S plus vector ST. When you simplify this addition, you have vector PT. This is called the polygon of vectors. Examples. Number 1, find the resultant of the vectors. You have A part and B part. Solution. The resultant of vectors is obtained through the addition of the vectors. A part of the problem, you add the three vectors together in this form. This vector can be made positive by interchanging the position of D and C. To CD, you can do the same thing here. You have DF. Hence, this addition. These two vectors, they have point C in common. Hence, when you add, you have vector BD plus vector DF. The two vectors, they have point D in common. When you add, you have vector BF as the resultant of the three vectors. B part, you add the given vectors together. Let's bring this and this together. They have 3 in common. Let's check. The first two vectors, they have point C in common. So when you add, you have vector AD plus vector DA plus you come here and factor out 3, you have this result. Now when you add here, because point C is common, you have vector BD times 3 in this form. If you check these two vectors very well, the two can be 0 if we have them in the same position. This is AD. We can convert this to AD. It becomes negative. The same thing that happened here, the reverse is what you have here. Now, vector AD minus vector AD is equal to 0 plus 3 vector BD. And you have 3 vector BD as the resultant of these vectors. Example 2. If PQR is a triangle, what is the sum of the vectors represented by vector QR, vector RP, and vector PQ? Solution. Figure 8 is triangle PQR. Then you add the 3 given vectors. Vector QR plus vector RP is equal to vector QP plus vector PQ. We cannot add at this point, but we can subtract if the two vectors are the same. To achieve that, you simply interchange the position of PQ. You have minus QP. When you subtract, you have 0. End of lesson 2. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared.